In this video, we're going to take another look at another way to conduct the Kruskal Wallis H test in SPSS. So here we have our hypothetical data of our three different group assignments, and you'll see how each group was identified by a numerical value, where 1, 2, and 3 indicated groups or people randomly assigned to an ice bath group, a massage group, or a control group. And so I'm going to go ahead and conduct the non-parametric uh, counterpart to the one-way ANOVA test. So I'm going to go to Analyze, Non-Parametric. This time, instead of going to Legacy Dialogues, I'm going to go to Independent Samples. Now, to carry out the Kruskal Wallis test, I'm going to click on Fields, and this is where I set up the variables for analysis. So the test field will include the outcome measure or the dependent variable, and that would be pain. So I'm just going to slide that one over here, and then I'm going to take the group variable, and I'm going to put it under groups here, and these are independent groups. Now I'm going to go to the settings, and I have to indicate what I want to do. So I'm going to click Customize Tests. I'm going to click the Kruskal Wallis one-way ANOVA, which is the non-parametric equivalent to analysis of variance. And I'm just going to leave it on all pairwise analyses. And so what this will do will not only evaluate overall if there's a statistically significant difference between the three groups, but the pairwise comparisons will identify where those differences reside. And so we have a lot of other options here. I'm just going to skip all over these, and I'm just going to hit run, and this will take a moment. And here we see the overall outcome of this analysis. So the very first table here indicates an overall summary of the hypothesis test, and the overall decision here is to reject the null hypothesis with a statistically significant p-value of 0.03. And notice here in item A that the significance level is 0.05. So in SPSS and most other software programs, unless stated otherwise, the default type 1 error rate will be set at 0.05. And since the calculated p-value from the analysis is less than that, we would reject the null hypothesis that there is no difference between the three groups. So moving to our second table here we have our total sample size, identified at 15, and our test statistic of 8.75 for our Kruskal Wallis H value with a degree of freedom of 2, and the asymptotic sig is our p-value of 0.013. Now, the advantage of using this approach in SPSS is that it will generate a box and whisker plot. And so what you see here are the three groupings of the three independent groups identified along the x-axis as the ice bath, massage, and the control group. And you notice here that the control group average was quite a bit higher than the ice bath and the massage groups. And the little dot here indicates a statistically significant finding. Now, as we go down to the next table here, here we see a summary of the pairwise comparisons. And so the pairwise comparisons, as you can see, will take ice bath to massage, ice bath to control, and massage to control. And the first column that we zero in on is the significant value. So we see that a value of 0.887 indicates that there's no statistically significant difference between ice bath and massage. The 0.009 and 0.013 indicate statistically significant differences between ice bath and control, and massage and control, respectively. Now the final column here is the adjusted significance value, and this is adjusted based upon the number of comparisons that are made. And so even with the adjustment, this is called a Bonferroni adjustment, that the differences between ice bath and control and massage and control are still statistically significant, and there is still no difference between the ice bath and massage. I won't go into any detail on explaining the other depictions here, the other visuals, but you can see that SPSS does provide a number of other graphs to describe the data. And so this will end our this video on another way to carry out the Kruskal Wallis H test.